In section 4, we are talking about matched or paired samples. So this is usually a test for means. Okay, matched and paired samples are usually a test for means. And in this situation, what we've got is we've got data that is two samples that are directly tied to one another. Okay, in the independent samples that we did in the first few sections, there's no way that we could make a one-to-one comparison from individual data values, okay? Because one of the requirements for those was that the samples be completely independent. So there's no way that you could, on a one-for-one basis, match up the data values. And in fact, the two samples didn't even have to be the same size. But for this, we do need our data to be paired, and so our samples will be the same size. And typically, like one of the classic examples of this is a before and after. Whether it's cholesterol level or weight or something like that. Before and afters are very, very common here. So this is kind of a long list of requirements, but they're not difficult to understand. We need simple random sampling. The sample sizes are often small. It's not a requirement. It's more like a comment. These are usually not real big samples. We're going to take two measurements from the same people, okay, or the same subjects or objects or whatever. One before and one after, usually. And then we have to calculate the difference between the two values for each person. All right, so we're going to get two samples, but we're actually going to subtract them so that what we end up with is one list of values, okay, that represent the differences. And so that's what we use for the hypothesis test. And then it's important that the population that we're dealing with, I'm on number 6 now, the population that we're dealing with is either normal or that we have a pretty large sample. Usually we say greater than 30. All right, and the device we're going to use in the calculator is the t-test. Okay, so here in example 10.11, we have a study that was testing the effects of hypnotism in reducing pain. So we have before and after scores for subjects A through H. All right, and a lower score indicates less pain. So this would be the data that you would be given typically. And what you have to do is you have to subtract in order to get the differences. And typically we subtract the after minus the before. Okay, so after minus before. So in that case, what we're going to end up with is quite a few negative numbers and one positive number. So this line here, the diff line, that's differences, that's going to be the data that we actually put into the calculator. So pause the video, take these values, there's 8 of them, and put them into L1 in your calculator. And then we will continue to do t-tests. All right, so the first thing we want to identify is the null and alternative hypotheses. So we have to think through this. Let me go ahead and show the alternative. All right, if we think about the claim, what we're wanting to test is whether or not this hypnotism program was effective in reducing pain. So if it's effective in reducing pain, then we'd end up with a lower score in the after column. And if we have a lower score in the after column, we're going to get a negative number, right? So the claim is basically saying that the mu for the differences, mu d, the d represents differences, mu d would be negative or less than 0. So that's going to be the claim statement. The opposite of that would be greater than or equal to, and then we divvy those up with the null and the alternative hypothesis this way. So in our t-test, we're going to tell it to use data. We're going to select the less than when we get down to the bottom, and we're going to get hopefully a p-value of 0.0095. Okay, so I forget, were we told our significance level? We were not. So let's just say it was 0.05. So at 0.05, this p-value is definitely lower. So we would reject the null hypothesis and say that there is sufficient evidence to conclude that the sensory measurements on average are lower after hypnotism. So there is a little extra work to be done in this section when hypothesis testing, because you have to take the raw data that's given and you have to subtract to find the differences, and then you can go from there. So there's actually one neat trick that you might want to try as you're doing the homework. I say it's a neat trick. It's outlined in the textbook as well. But you can take the before and put them into L1, and then you can take the afters and put them into L2, and then you can quit and go back to the home screen, and you can tell your calculator to subtract L2 minus L1 and store that in L3. So if any of you have any questions on how to do any bit of that, the store button, by the way, on your calculator is right above the on key. It's the one that says STO, and there's like a little arrow. So that may be helpful to let the calculator do the subtraction and store it in a list all in one swoop. The downside is you do have to type all of the two sets of the original data. So if the subtraction's easy, if it's whole numbers, then you might not want to do it. If it's ugly decimals or something, then it might be worthwhile. So that's just a little hint here, or a little tip. Your homework is here on the screen. 115 and 122 in particular are full hypothesis tests where you'll have to do that subtraction. So good luck on this. Let me know if you have any questions.